Cast is now starting. All attendees are in listen-only mode.
All right, it is 7 o'clock, and that means it is time for us to get started. So first of all, good evening to everyone that is attending. We've got a good group here this evening, and super excited to talk with you a little bit about what we do here at the National Weather Service. So before we get started on this webinar, some housekeeping things. Well, first of all, introductions, I guess, would be helpful. My name is Bryce, and I'm a meteorologist here at the National Weather Service. And I am joined by my colleague Hayden Frank, who should be on the line too. Hayden, you there?
Yes, I'm here. Glad so many people can join us on this nice evening.
Yes, thank you. So Hayden, you'll be hearing more from Hayden during the second part of the presentation this evening. I'm going to go through the first half, and then I'll throw it over to Hayden for the second. And basically the way it's going to work is we're going to go through this presentation. Everyone is muted, but if you do have a question that comes up or even in the observations you want to make, but especially questions that you might want to try to stump us with, throw them in the chat or the question feature, and at the end of the presentation, if we have any questions that you guys have asked, we will go through those and try to answer them as best we can. All right, that all sounds good, then we'll just go ahead and get started here. So just to start off, we are doing a series of informational webinars. This is actually, we've had several event reviews that we have presented already, and hopefully you guys have tuned into that, some of those as well. You can see here in this list, this is the first of several other types of webinars. So in the coming weeks, next week we have our Weather 101, so basics intro to meteorology and weather. Then the following week we have a marine forecasting webinar scheduled for, mostly for boaters, focused on boaters, but really open to anyone and useful for anyone that's interested in the weather. And then later on this summer, probably in July and August, we're going to have more, including severe weather 101, tropical weather, even some on radar and satellite interpretation from meteorologists in our office, how to navigate our website, all sorts of stuff. So we encourage you to hopefully keep following us on social media if you're not, and we will be announcing those webinars as they come up. Like I said, my name's Bryce, and I'm joined by Hayden. So we've kind of already gone over this, who's going to be presenting tonight. All right, so to get it started, I wanted to start off with kind of a cool thing I found. So this is actually, I'm not going to read through the whole thing. It's on the screen for you to read if you'd like, but this is a transcript of the very first official Weather Bureau observation that was taken in Boston at the old State House, at basically the first iteration of our National Weather Service. And we're going to go through at the beginning here the history of our office and where we started and how it's moved through the years several times. And this was where we started off, and this is the very first recording of an observation. So somebody, was saying that at 8 a.m., the height of the barometer was 29.72 inches. It was 52 degrees Fahrenheit. Direction of the wind was from the west, 3 miles per hour. So really, just fascinating. And the identity of this observer is not really known, but they've narrowed it down to one of 3 people, either the Sergeant S.E. Cole, Private Black, or Private Hunnicky, I think is how you say that name. They were all members of the Signal Service of the U.S. Army who would have been taking those observations at the time. So pretty fascinating. Way back in 1870, Boston's pretty unique in that our history goes so far back as a city, but even with the weather, it's really cool to know that as well. So that was taken actually here. You've probably recognized this spot. It's a major tourist attraction in our city, the old State House. And the Weather Bureau, as it used to be known, was originally located here back starting in November 1st, 1870. And you probably recognize this is a really famous spot. I believe the Declaration of Independence was right off that balcony right there, site of the Boston Massacre, many other historical things, and including our office location, which is pretty neat. Then in 1871, in January that year, we moved to 103 Court Street, and you see a picture of that here, kind of a nondescript building, but another location in that same area of kind of downtown Boston. We just moved buildings. Then in 1875, we moved to the Equitable Building at the corner of Milk and Devonshire Street. You see the picture here, just another building. I'm not sure if it still looks like that today. I'm sure it does. So you may recognize it if you're out and about down in Boston. But that's where you look in the bottom right of the corner of that black and white picture. It's kind of cool seeing, looks like carriages or buggies. I don't know, old school cars. It's hard to tell, but it's definitely old. Then in 1884, we moved to the old U.S. Post Office and Courthouse, which you may recognize from Post Office Square is where that was located. Now I'm not sure if this building is still here or not. I know Post Office Square is familiar to me because there's a park on the top of it now, and there's a parking garage underground that I like to park at on the weekends. That's how I know Post Office Square, but we actually had our office there way back in the 1800s. Then moving on to the 1900s, 1929, the Young's Hotel was an interim quarters during construction of the post office and courthouse, which makes me would lead me to believe that it doesn't look, similar to the picture I just showed of the old post office. But during that construction period, we moved into a hotel. Now, after this, it's unknown exactly where we went, but if we went back to the new post office and courthouse, or if we moved directly to Logan Field. So that is one of those questions that will go down in history unless somebody finds, if you figure it out, send us the answer. But we do know that on January 1st in 1936, the official observations for Boston were shifted to the airport, to the observation station at Logan Airport, and for the office of the Weather Bureau. So, and the Logan Airport actually remains the official observation site for Boston to this day. And then a couple more shifts here. So staying at Logan Airport in 1951, we just moved buildings to the Toutwell Building, gate number 11. In 1963, moved still at Logan Airport to the General Aviation Administration Building on Maverick Street. And in 1965, the Weather Bureau became part of the Environmental Science Services Administration, or ESSA. And the first ESSA administrator was actually a Boston native and graduated from Harvard and MIT. So a little claim to fame for the ESSA from Boston. All right, moving into the 70s, this is kind of transitioning to more familiar to what we know today. The Weather Bureau became the National Weather Service and was placed under the National Oceanic and Atmospheric Administration. Now, many people may have heard of NOAA. It's kind of similar to, a lot of people know about NASA, but NOAA is actually the National Oceanic and Atmospheric Administration, more focused on the science of Earth and its atmosphere. And so it was placed under that in the 70s, and our office was continuing to be located at Logan Airport at that time. And then in the 80s, we moved just a block down on Harborside Drive to the Massachusetts Technology Center, where we were until 1993. The first move that I was actually around for. I was alive in 1993. Okay, before we get to the modern era of the Weather Service, I found some interesting tidbits about other offices located in southern New England through history. So we'll go state by state, starting in Connecticut. So these are basically where we had locations that offices were sometimes just taking observations a lot of times for the Weather Bureau. Small offices that were staffed with a few people and taking up weather observations. Not the kind of centralized offices that we have today with lots of people in one place doing the forecasting. So, Bridgeport from 1948 through 1994. And also you'll notice these asterisks by some of these dates. That means that we still have automated observations continuing from the date you see for each of these locations through today. So they're still recording data. Hartford has moved locations several times. We started in downtown Hartford, then went to Brainerd Field in 1939, and then to Bradley Field, where we are today, back in 1954. Middletown, New Haven, New London, Putnam, all of these had, Weather Bureau location that was at least observing the weather. Most often, they were sending in observations. Now in Massachusetts, we have a pretty cool site in Blue Hill, which has been recording weather observations from 1885 through today. And many of you, if you're weather enthusiasts, may have visited the Blue Hill Observatory in the Great Blue Hills. Today, you can actually, pay a couple dollars and take a tour, and it's really fascinating. Recommend it. I've done it, and it was really, really neat as a weather junkie myself. Really cool to just see such a historical thing. They have many different, they have an ASOS or automated surface observation system recording measurements. And they also have several other different types of redundant technology to really get an accurate read for, from the 1800s through now. It's really cool. Now, Chatham has been a site since 1970, and it is actually still the site of our upper air station. This is a picture I took last week, actually, on a trip I took out to the Cape. And so what this is a building where we launch our weather balloons from twice a day. And so it's a very scenic location. It's got to be one of the most scenic. About 92 offices in the Weather Service have our upper air sites, or they launch weather balloons. And this has got to be one of the most, if not the most scenic spots, I think. Just look at that. It's a really nice spot. Martha's Vineyard, Nantucket, and all sorts of places in Massachusetts. Oops. And then Rhode Island, Block Island through 1950, from 1880 to 1953. Narragansett back in the early 1900s, and then Providence, where we still have a climate site today, moved around as well, from Browning University to downtown Providence, and now it's in Warwick at TF Green Airport. Okay, now into the modern era. 1993, I was 3 years old, but while I was 3 years old, they were moving the office from Boston to Taunton, Massachusetts. This is our first big move. Prior to this, we'd been shifting around downtown Boston. Now we finally moved out to the suburbs, and it was a part of what's known as the NWS modernization. And this new facility was built in Taunton at the Miles Standish Industrial Park and co-located with the Northeast River Forecast Center, which was formerly in Bloomfield, Connecticut. Also at this time, a Doppler radar was installed, which is how we track the storms coming into southern New England. And we have a slide about that in a minute. So with this move, the Taunton office assumed the warning responsibilities from those many smaller weather service offices, some of them that I mentioned in Hartford, Providence, and Worcester. And many of the staff at these smaller offices were actually brought into the Taunton office, and many of them still work here today. So really cool. We've had a lot of people that have been able to stay in Southern New England for a long time. And these pictures just show cool perspective of the operations area, is what we call it. So this is where all the forecasters on duty are making the forecasts, putting out the watches and warnings. So you can see kind of the older workstations there. This is back probably from the early 2000s or the early 2010s. Then, just a couple of years ago, we got a nice brand new facility in Norton, all the way over in Norton, Massachusetts, which is a stone's throw away from our old office. Literally, you could probably, if you were strong enough, throw a stone. It's right over the town line from Taunton to Norton. And you can see it was a nice new building, and we're still co-located with the RFC, so we share that building with them. And we've really enjoyed it so far. I've got some pictures of the inside of it, and you'll see why. So this is a picture of some of the inside, the operations area on the right. So you can see we've got lots of space. We got a nice big situational awareness display, we call it, on the wall, that we can look at satellite, radar, observations, webcams, and we can have it on local news stations to monitor any weather that's going on. So we really enjoy that about it. And if you see the bottom left is a picture of our conference room, where many of us will oftentimes meet for staff meetings and conferences to seminars to learn about the newest, latest and greatest in the scientific research of meteorology. And one of the favorite things about this building is on the left, you can see the big giant windows. So we've got nice big windows. We actually see the weather. In our old office, the windows were tiny little basement type windows at the top near the ceiling. So big improvement there. Now I mentioned our Doppler radar that was built in '93 over in Taunton, and I said it was a stone's throw when we moved to Norton. And you can see it's true, because this picture on the top left of the radar in front of that big cumulonimbus cloud was taken from the backyard of our office, our new office. And it used to be right across, and the radar is right across the street from our old office. So it's right there, and our ETs can get to it easily, which is nice. So that big dome you see from the bottom in the bottom left pictures is covering a giant dish, and you can see an electronic technician there for size comparison. It's a really, really big dish inside that is spinning around and sending out electromagnetic pulses. And if you want to know more about exactly how we use that, then tune in for our Weather 101 and our Severe Weather 101 webinars in the future. Little plug there. So the Weather Service has a mission statement, and basically, to sum it up, it is that our duty is to protect life and property. We want to maintain records. We want to provide the best service that we can to our public in our CWA, or county warning area, which I'll show you guys here in the next couple of slides. We are basically trying to be leaders in science, research, training, and outreach. So I've included several pictures here of different aspects of some of our job. You can see one of our older forecasters and hydrometeorological technicians, Kim, on the bottom left, presenting an award to one of our, I think that might be one of our co-op observers. You can see on the right our operations area during some sort of weather event. In the bottom, in the middle, you can see as somebody's deployed to a emergency operations center, which we'll get into exactly what that means later. And then top middle is a picture from our really fun event last year called the Hurricane Awareness Tour. And that was back in Southern New England for the first time in, I think, 8 years. And it was a lot of fun. I hope you got to enjoy to come out and see that. But that was fun for us to do. And then we teach classes like Skywarn classes, training on severe weather and how to spot severe weather and send us reports. So all sorts of stuff goes on here, and we'll get into more detail a little bit later. But what is the National Weather Service? So when people think of meteorologists, they tend to think of people on TV. And the way I like to describe it kind of is like an iceberg. So we are like the National Weather, we are the weather behind the scenes. So when you think of meteorologist, you think of the forecast you get on TV, you hear on the radio, you get on your phone. And that's true. But if you see the the base of that, beneath the water, the foundation for all of that comes from the National Weather Service. So many different facets. There are 122 offices just like ours across the country issuing warnings and forecasts. There are many national centers dedicated to certain types of meteorology, which I'll show you here soon. There are river forecast centers. Northeast River Forecast Center is located here. There are observations, a whole network of radars, satellites that we're launching into space, weather balloons that are going up twice a day, 90 plus locations across the country, our fleet of aircraft, lightning network, buoys, and then volunteer spotters. So all sorts of things are at the foundation that goes into getting you the forecast through, a lot of times, the TV or the radio, the newspaper. A lot of that's coming from us originally. So we're a federal agency. We, like I said, we have 122 offices and observe and forecast the weather. We are the only agency that is allowed to issue things like severe thunderstorm warnings when you get those on your phone, tornado warnings, that kind of thing. By federal law, we're the only agency or organization that can issue those. So really just the one-stop shop for forecasts and severe weather warnings. So this is a map of what I just described, those 122 offices. So these are all the weather forecast offices in the country, including places like Guam, Puerto Rico, Hawaii, Alaska, and they basically are like a puzzle that, when put together, blanket the entire country with weather coverage and, you know, keeping people safe and saving the economy dollars, hopefully. Now, just to zoom in on our area, so this is where, if you live in any of these counties, this is the office here in Norton is your home office. So this is our county warning area. We forecast for almost all of Massachusetts, save for Berkshire County, which is taken care of by our friends in Albany, and some of Connecticut, much of northern Connecticut, and then all of Rhode Island. Now, we did used to, until several years ago, cover also 2 counties in New Hampshire, southern New Hampshire, but we, several years ago, gave those over to our friends up in NWS in Gray, Maine. Now, here's a quick map of the Weather Service regional headquarters. So the Weather Service is kind of broken up into several different regions. So we are in Eastern region, which makes sense. And our headquarters is located in Bohemia, New York. And we have Central region in Kansas City, Southern region in Fort Worth, Texas, Western region where I came from. I used to work in our office in Spokane, Washington, several years, and our regional headquarters was located in Salt Lake City. And then you have the Pacific and Alaska regions have ones all to themselves. And then our national headquarters is located in Silver Spring, Maryland. Now, we also have several national centers that actually are operational for forecasting. So we have one of the most, maybe the most well-known, I think, to general public would be the National Hurricane Center in Miami. They're obviously focused on, you guessed it, hurricanes, tropical storms, tropical depressions, everything tropical. They are the experts on, and work together with the Florida and Gulf Coast and East Coast offices when we have hurricanes come up our way, work together with the Hurricane Center to put out forecasts. There's the Storm Prediction Center for severe weather junkies like me. You may be familiar with the Storm Prediction Center in Norman, Oklahoma, right in Tornado Alley, which makes sense. They have focused, they're 365, 24/7. They're focusing on only severe weather. That's 95% what they do. That's their bread and butter, severe weather. And you have the Space Weather Prediction Center. Yes, that's a thing, space weather. You have the Aviation Weather Center in Kansas City, the Weather Prediction Center, WPC, and also in College Park, Maryland. That's also the location of the Ocean Prediction Center, Climate Prediction Center, and the Environmental Modeling Centers. So any facet of meteorology, climatology, anything to do with atmosphere, the oceans you can think of, it's probably got coverage here in NOAA. Another thing that we deal with here at the forecast office is we work with the CWSU, or the Center Weather Service Unit, and these are aviation-focused regional centers. And you can see that how they're broken up across the country into these regions that they cover. And so ours obviously covers most of New York and all of New England. Finally, we have the river forecast centers, which forecast for the rivers. The Northeast River Forecast Center forecasts for almost all of New York and all of New England, just kind of like the CWSU. And then we have all of these other regional centers as well that forecast with, they're staffed with a team of hydrologists, and many of them are, trained in meteorology and hydrology. And so they're really good at what they do, and they forecast the rivers. All right, and with that, I am going to hand it over to Hayden. So Hayden, you're up.
All right, great. Thank you, Bryce. Bryce gave everyone a really good overview of the history of the Weather Service and general operations. I'm going to kind of go into a little more detail with our office and our duties and responsibilities. So at the National Weather Service in Norton, we are a total of 26 employees made up of meteorologists, electronic technicians, and administrative support. Now, the thing with our job is weather's 24/7, 365 days a year, so are we, which means even on days like this, when the weather is really quiet, we always have at least 2 people on shift, whether it's New Year's or Christmas, July 4th, there will always be at least 2 people on shift. Now, that changes if we would have severe weather, a winter storm. We may have 4, 5, 6, 7 people on shift at once. So that portion is dependent on weather. And as Bryce kind of gave you in the overview, we're issuing forecasts. Our mission is the protection of life and property, and watches and warnings are a big portion of that. And we also have the luxury of being co-located with the Northeast River Forecast Center. So breaking our staff down a little bit more, we have 5 lead meteorologists and 5 meteorologists. So the lead meteorologist, like myself, that's someone that's going to supervise the shift. So managing everything that goes on during that shift, whether it be collaborating a winter storm or talking with an emergency manager, that goes to our responsibility. And then we have 5 meteorologists who basically are putting out weather forecasts, and they also are making some of the decisions too. We have a senior service hydrologist who specializes in potential for flooding, flash flooding, and also is coordinating with the River Forecast Center. We have 2 hydrometeorological technicians who really help us assist in operations. We'll answer a lot of phone calls, talk to the public a lot of times. And for electronic technicians, they'll focus on the equipment. So if something with our computer systems goes down, our radar goes down, that's something that crucial we need up, they'll get to work on that. And the administrative staff, well, like any business or agency, we have a boss, that's the meteorologist in charge, who oversees all the aspects of our office. We have a warning coordination meteorologist. That person's responsibility is to talk with the external partners and help us with collaboration and kind of growing in getting our forecasts and information out to people that can use our products. We have a science and operations officer. That person focuses on the research and training of the staff. With a job like a meteorologist, there's always new technologies, new model data coming into the office that we can utilize to give the best information possible. Electronic systems analysis, they manage the electronic technicians, so they're keeping up to date with the latest on the computer systems, our equipment that measure the temperature, wind speeds, all across of southern New England, so they're managing that. We have an information technology officer. They focus on the computer systems, and an administrative support assistant, obviously, who handles administrative stuff that comes into the office. So it's a whole team of of folks that really work together to get the best products out, to the public and to emergency managers, town officials, and we'll discuss that in a little bit more detail as we move along in the presentation. So as Bryce alluded to earlier, there is a Center Weather Service unit. So each FAA Air Traffic Control Center has this embedded National Weather Service service unit. And what those folks do is they actually work with the air traffic control folks. We coordinate with these folks because we issue aviation forecasts. And those are for several airports, which we'll discuss in a minute here. But for example, Boston Logan Airport, average 5,000 plus flight operations per day. So that's a lot. They're dealing with certain issues like icing, turbulence, thunderstorms. So we're always coordinating with them. And then the folks at the CWSU, those meteorologists are then briefing the FAA. So we're collaborating, and then they're collaborating with the FAA. So it's a very structured situation where we're all collaborating with each other and getting the best possible information out, so the folks can make the best decision over at the FAA with flights. And we're going to take a closer look at this on the next slide here. So our responsibility is to issue aviation forecasts for 9 airports. So Boston, Bedford, Providence, Hartford, Westfield, Worcester, Hyannis, Falmouth, and Nantucket. We're forecasting wind speed, the visibility of the terminals, rain, snow, thunderstorms, and the ceiling height. Is there going to be lightning? That all affects on how planes can land. If there's bad weather conditions, the FAA requires a larger amount of time and spacing between landings. As you see, most weather delays are as a result of, most flight delays, I should say, are a result of weather. And even on a quiet day, a major airport like Boston, if the wind shifts from the west to the east, that has a huge impact on how the planes can land and take off, and they have to reconfigure their runways. So there's definitely a lot to consider, and that's why we're in constant collaboration with the folks at CWSU, who are, again, talking to the folks at the FAA. Fire weather forecasts. This is something that we've spun up in Southern New England over the last, say, 15 years. And it's an important factor here, but especially out in the Western United States, where they have these wildfires that can get really out of control. And one thing that's important to remember, we don't forecast fires, or we don't forecast fuel moisture in the ground, which causes fires to spread out of control. But what we do is we forecast the elements that can exacerbate this situation, such as temperature, relative humidity, wind speed. Is there lightning? You can get dry lightning, especially out in the Western United States, which can cause wildfires to spin out of control. And there's also something called prescribed burns. They do them even in Southern New England, especially down on Martha's Vineyard and portions of Cape Cod. But they're particularly done out west, where they actually burn a strip of land, an area of vulnerable land, which is subject to wildfires, to kind of prevent them, because if the land's already burnt in an area, that fire can't expand. But it's something very significant, and we have different fire weather partners that we speak with in terms of the wind speed, the relative humidity. All those factors go into their decision making. If there's how much staff they're going to have out that day, are they going to be able to do a control burn, all that type of stuff. They're looking to us to give them that weather information. And marine forecasting. Being a coastal office, we have a marine responsibility that extends 40 to 60 miles offshore. What does that consist of? Well, wind forecast, wave height forecast for both the Massachusetts and Rhode Island coastal waters. And if you take a look at the map here, you can see the Southern New England coast has a lot of little interesting nooks and crannies in it, which make forecasting a bit challenging at times. because you can get what's called a funneling effect. If you've ever walked in the, downtown Boston or New York City in between some buildings, that wind can really accelerate in there. Well, the same thing can happen where you have those narrow streaks of water, and you can get, a narrow corridor of strong winds and high seas. So we, talk with the marine, our mariners about that, and try to, constantly improve our forecasts and our wave height forecasts. We have a lot of recreational boaters out there this time of year, but even in the winter time, there's obviously, we're in a big fishing industry up here, where you have, fishermen out there and in really bad weather. One of the things we forecast for them is freezing spray. If it gets really cold, that ocean spray can freeze on the boats and actually can bring them down if you get enough of it. So, we talk with mariners, we talk with the Coast Guard because they're involved in search and rescue, unfortunately, at times. So, again, one of the things you'll hear us talk about is collaboration. We all really have to be communicating with each other to get the best possible information to everyone out there and the best possible results. So that kind of leads into decision support services, and this is information for emergency managers and other decision makers. So, I've been in the Weather Service for over 20 years now. Hard to believe. But one thing that's certainly changed, early in my career, we just would be, we'd be forecasting. We'd still communicate with emergency managers at times, but it's become a lot more extensive. And for example, if we're forecasting 8 to 14 inches of snow on a Sunday versus 4 to 8 inches of a wet snow during rush hour on a Monday evening that can bring down power lines and trees, that's obviously much more significant to the emergency managers, town officials, school superintendents. So that's the type of information we're briefing on. Obviously, these folks need to, know the amounts, but when we're giving this information, their biggest concern is when's it going to start? When's it going to stop? Is it going to stick immediately on the roads? Are we getting 1 to 2 inch hour rates where the snowplows can't keep up? Those type of things is what we're doing, and we send out emails, to those folks specifically. If it's a significant event, we'll have conference calls with them, phone briefings. Actually, Bryce is working on spinning up video briefings too as we move into more technology and better ways to communicate. So this is something that's really evolving quickly in the Weather Service, and decision support services is probably one of the most important things we do with the National Weather Service. And I kind of touched on this already, but the big thing here is the communication, and that's why we have all those arrows pointing from the National Weather Service to the emergency managers, to the media, to the television meteorologists, because we all need to be communicating with each other, and we do. When we send out information, we include our television meteorologists, we include emergency managers. We have a special chat where we can speak with all these folks and they can speak with us too. It's not a one-way street, it's a two-way street. And whether you're in weather or whatever type of thing you're doing, the more collaboration you have, the better people are able to understand and receive and interpret your products. If folks don't know what our forecast means or know what to do, then the forecast is useless. And that's why this has been such a push. This DSS support is briefings, knowing what to do. And the one thing that we do, we give the information, we give the facts, and then the emergency managers and those town officials, they make the decision whether they're going to close certain roads or schools are going to be closed. That's not us, but we give the information of the timing of the weather and the impacts, and that's on us, and then they make the decisions. So another thing with I kind of was talking about DSS meteorology for significant weather events, whether that be a major blizzard, a high wind event, but there's Regular events that happen, obviously a lot of these have been postponed, unfortunately this year because of the COVID situation. But things that we normally provide on-site service, we'll actually send a meteorologist in the area embedded with the emergency management, say the July 4th fireworks in Boston, the Boston Marathon, the Brimfield Antique Fair. There's a lot of different events that we'll kind of embed ourselves, so we can talk with someone right there. They have the luxury of having us on site, and we're able to talk with them too, which is great. There were 2 instances in the last 10 years where thunderstorms were moving in during the July 4th fireworks show. Because we had a meteorologist embedded there, that person was able to tell them, to evacuate into the tunnels out ahead of the thunderstorm. In another situation, they actually sped up the fireworks show by 30 minutes so that everyone could see the fireworks before the thunderstorms began. And another example would be the Boston Marathon. And unfortunately, when those bombs went off in 2013, it wasn't known. Could they have been a dirty bomb? So what they asked of us was to run a high split model, and what that is, it basically will tell them which way the smoke is going to move in case there was a poisonous gas in there. Fortunately, there wasn't, but those type of situations are what our primary job is in the protection of life and property. And collaboration, we work with a lot of, different organizations, especially, being a coastal office. We're constantly working in, say, coastal inundation projects. I know today we had a meeting where we were, discussing different areas of storm surge along the coast. How that's impacts certain areas, and how we can modify our forecast to get the word out better. We have a Hollings program where a student will come into our office and work on a project for us, and that collaboration really helps us out. Harmful algae bloom, knowing the wind direction, the weather conditions, that type of information has a big impact on how those things evolve, during the summer. So, the collaboration efforts are really crucial, so that we can all be most successful in getting, the best information out to those decision makers. And federal and state collaboration. So one of the things we're involved in is something called Storm Ready, where, say, a town, a hospital, we've done this for amusement parks or ESPN, where a certain company, business, or town will submit a plan, and it doesn't matter what the plan is per se, as long as that town has a plan for what they're going to do if there's severe weather, what they're going to do if there's a blizzard. Having a written plan, knowing who to contact, where people should go during these events, who's going to be notified, is really, the best thing you can do to reduce the impacts of a severe weather. We're never going to prevent severe weather, but we can reduce the impacts and, help save life with property by making these necessary adjustments based on what weather is expected. We do different workshops across the area in terms of, communicating with the FAA, fire weather workshops. We have those folks come in. Actually, today we actually had a meeting with our state drought task force, given how dry it's been over the last week. And in terms of, there's also a lot of collaboration with universities, which if we go to the next slide there, Bryce, you'll see that University of Connecticut, University of Massachusetts, we've worked on a rip current model, trying to forecast, say, depending on the wind direction, the amount of wave action, which beaches are going to be most vulnerable to dangerous rip currents. every year. Different things with Massachusetts Institute of Technology. They have a wave model that they run that can forecast wave heights, which is really helpful. So we're all communicating with each other, and that's really helping us to get the word out and kind of evolve here as technology increases and our capabilities of being able to disseminate a lot of this information increase as well. So, you know, in terms of other collaborative relationships, you know, customary advisory boards, amateur radio, Skywarn, what those folks are, if we have, say, severe weather, they have a whole network where they're communicating with each other in different towns, different areas, and they relay to us if there is, say, down trees in such and such a town. When we had the significant severe weather outbreak on May 15th, they were really getting a lot of good information to us, knowing, you know, what was going on. There's a lot of power outages coming in central Massachusetts. That really helps us out. We have the radar, but being able to confirm that those damage reports are occurring helps us issue warnings further downwind and as we get into northeast Massachusetts. The Steamship Authority, well, we have, you know, these vessels that are going from Nantucket to the Cape, to the Vineyard, back and forth. What are the wave heights? What are the winds? Are we under forecasting the winds? Do we need to increase them? Those type of things help us out. You know, Blue Hill Observatory, Bryce talked about, we do a lot of collaboration with them. We do presentations all the time. TV meteorologists, we're working with them as well. And information on our web, for those who've been to our website, weather.gov/Boston. There's a lot of different information there, whatever you really need, forecasts, climate data, storm reports, radar and satellite, weather maps, pretty much whatever you need. And the whole page is very user-friendly. You just basically click on the area that you want the forecast for, and you'll get a 7-day forecast. If you want forecast for out over the ocean, you have a boat, you're going out there, you just click on that and you'll get that type of information. And one of the things that we've kind of spun up to over the last couple of years is enhanced hazardous weather outlook. And what this does is, without reading a bunch of text, over the next 7 days, it'll highlight the main weather concerns over that 7-day period. Whether it be, say, high surf, let's say it's going to be excessive heat, and it basically will start with non-limited, elevated, significant, or extreme, and you'll be able to scroll through really quickly and see what the biggest impacts are over the next 7 days. So that's a real general overview, but it gives you the primary look at what hazards we're really concerned about. And social media, obviously this has really grown over the last 5 to 10 years here. We have Facebook, we post regularly on there. Twitter, that's really great too. We put a lot of information that we can't put in, say, a graphical or text forecast. Social media sites, we can do a loop of timing of when we expect say snow to develop in the wintertime. If you're out in you're going camping or whatever, what time is the thunderstorms coming? Well, we can kind of time that out for you, show you kind of a loop there of what things are going to look like, being prepared to take shelter if needed. So there's a lot of things we can do in social media. And we also have a YouTube account where we have a lot of information on presentations that we do, different information on, say, safety, whether it be rip currents in the summertime or thunderstorm safety. There's a lot of great information out there. So definitely visit those sites on our social media. And if you're interested in learning more about the Boston office and in detail, if you go to weather.gov/box, that will give you kind of the leeway to go there. And if you go under local programs and click on that link, you can kind of get a history overview of kind of what Bryce gave at the beginning. But I'll have everything written down for you if you're interested in that. And we want to thank you for your time for attending, and we're
Yes.
happy to take any questions. Like Bryce said at the beginning, we have a lot of more of these webinars scheduled, over the next month or two. So definitely looking forward to that.
Yeah, hope to have you guys join us again for those. And if you have any questions, real quick, type them in the question box. We do have 2 in there now that I will click on. Let's see. So somebody asked, do you work with AccuWeather that is seen on TV? That's a great question. So yes, we do to a certain extent. Not necessarily directly with AccuWeather, but indirectly. AccuWeather is a member of the private sector of the weather, what we call the weather enterprise sometimes. Basically, the combination of public meteorology, which is generally the government, which is NOAA, the Weather Service, and the private sector, companies like AccuWeather and the Weather Company and the like, and academia, meteorology in academia. And so that's kind of the weather enterprise. And we all work together. We're all kind of one big team. We like to think of it ideally. And we, the AccuWeather is using a lot of our freely available data, like the radar and the satellite data, come from the Weather Service. That you see, if you see the radar or satellite on the news on any station, this not necessarily AccuWeather, but any station, that data is coming from the Weather Service, and it's free because it's public service from the government. And in general, these private companies could not afford to run, build and maintain a nationwide network of billion-dollar satellites and radars, and so they are able to use this that is paid for by everybody's taxes. I think I once heard that the Weather Service only costs every American about the cost of a cheap cup of coffee each year through taxes, and so about $3 every year. And everybody is able to get free forecasts and warnings and all this data, satellite radar observations, everything for free for $3 a year from taxpayers. So it's a really great deal and really great service to the American people. And we are always working with our TV meteorologists. So they are coming into our office many times for our seminars to learn with us. We're in communication with them during severe weather operations. We have a thing called NWS Chat, where our TV meteorologists will be in there and they can ask us questions. We can tell them what we're seeing on the radar, if we have any ideas of what storms might be strengthening and whatnot, so they'll have a better idea to get on the air and help warn everyone. So we have really good relationships with ours, and I think really in the Boston area at our office we have a exceptionally good relationship with our TV meteorologists.
Yeah, I'd second that, Bryce. I think we're really fortunate.
We are
Great relationship.
So, we do. We've got some great TV people out there. So great question. And see, the only other question I see is, of course, one we hear a lot. What is your stand on global warming? Well, all I'll say on that is our NOAA keeps climate records, and our the climate data records point to show a increasing trend in that global average temperature. So the globe is warming up. What exactly that's from and why and over what scale and everything else I will leave to the experts, which are the climatologists. So I would point you to the Climate Prediction Center. They probably would have a lot more expertise than we would as meteorologists, because they study that for a living. Climate is what they're all about. So I would point you to the Climate Prediction Center, unless Hayden has anything else he wants to throw in about that.
No, that would be the best thing to do. And the one thing to point out too is that climate change isn't the same everywhere. So we know the climate's warming, but the impacts, in a certain area are going to be worse or less than another area. So that's what really remains to be seen. Some areas are going to be more impacted than other areas.
Yep.
unfortunately, those on the coast, are obviously vulnerable to sea level rise, which is definitely going to be it's a concern now, but as we get, 20, 30, 40, 50 years from now, it's going to be even a bigger concern.
Exactly. And I haven't seen any other questions come in, so I guess we will end it with that. And I'll say once again, thank you guys for attending. And I hope that you learned something and enjoyed it. And hope you guys have a great rest of your evening and hopefully see you next week.
Yes, thank you, everyone.
Bye,
Really
everyone.
appreciate it.